Good morning. Let us start our lesson. Our topic today is on further logarithms. So write down that. Introduction. When a number is written in the form a power n is equal to b. When a number is written in the form a power n is equals to b, then a is called the base. A is called the base, while n is called the index. A is called the base, while n is called the index. This can be written in logarithmic. Notation. This can be written in logarithmic notation as log b to base a is equals to n. This can be written in logarithmic notation as log b to base a is equals to n. So if I'm given log b to base a equals to n, that means a power n is b. Example one. Write in logarithmic form. 2 power 5 is equal to 32. Write in logarithmic form, 2 power 5 is equal to 32. So that one will say it is log 32 to base 2 is equal to 5. So that is the logarithmic notation. Hope we are together. Then, if I have, let's say, 3 power negative 4 is equal to 1 over 81. How do you write that in logarithmic notation? It will be log to base 3 of 1 over 81 is equal to negative 4. Or log 1 over 81 to base 3 is equal to negative 4. So that is the logarithmic notation. So we write very, very fast. Then example 2, write in index form. So write that in index form. So that would be 4 power 1.5 is equal to 8. This one will be 10 power 3 is 1 out. But A, but B. So you have to understand that how to convert. So up to that point, you should be able to convert from index form to logarithmic notation and vice versa. So if you have given a logarithmic notation, you should be able to convert to index notation. Or index notation, you can convert to logarithmic notation. So the next thing we are going to do is we look at the laws of logarithm. Laws of logarithm. And this is very, very important, and we have to get it right. We are going to just state the 3 laws of logarithm, the basic ones, and then I try to elaborate something because there is a misunderstanding among some of you. Number 1, logarithm of A, log A plus log B is equal to log A B. So we cannot change that law. We cannot change that law. We cannot change multiplication with addition. No. So if there is no law that says we multiply logs. No. So it's about adding logs. So add logs is the same as the log of the product AB. For example, if I'm given log 2 plus log 4, then that is log into bracket 4 log 2. So that is the meaning of that law. That log A plus log B is log A B, meaning if I've given log 2 plus log 4, then you take log into bracket 2 times 4, which is log 8. And you should write very well there. Then another one is log A minus log B. So this one is log A over B. For instance, if I'm given log 16 minus log 2, then this gives me log 16 over 2, which is log 8. So that's second law of logarithm. And then the third one, log A power n is equal to n log A. Log A power n is equal to n log A. So we will apply those laws in answering some questions. NB. So we all know that when you raise a number to power 0 is 1. So, like for instance, if I have 10 power 0, you know it's 1. 10 power 0 is 1. Therefore, log 1 is 0. Why am I saying log 1 is 0? Because if I write here log 1, it means it is to base 10. For log 1, you don't have to write base 10. Sometimes they write base 10 or they leave, you can leave it. So log 1 is 0. Now, for instance, if I have something like 10 power 2 is equal to 100. Therefore, log 100 is 2. Log 100 is 2. And so forth and so on. So like 10 power 3 is 1,000, and therefore log 1,000 is 3. Now,
3.
then if I have 10 power negative 3, this is 1 over 1,000. And therefore, log 1 over 1,000 is negative 3. And then another thing you have to take note is that logarithm of a number can be 0, positive, or negative. So logarithm of a number can be 0, positive, or negative. And then you should also take note that logarithm of a negative number do not exist. Logarithm, like I cannot get logarithm of negative 2. Though the logarithm of a number can be negative, but I cannot get the logarithm of a negative number. Similarly, logarithm of 0 do not exist. Logarithm of 0 do not exist. Example 2, express in terms of log x, log y, and log z. Express in terms of log x, log y, and log z. So we want to express in terms of log x, log y, and log z. So we use the law of logarithm. And you know, if I have x squared y cubed, that multiplication, it can be split as log x squared plus log y cubed. Because I'm dividing, we say minus log 10z. So, according to the third law of logarithm, log x squared is 2 log x. Log y cubed is 3 log y. Then minus in brackets, log 10z can be rewritten as log 10 plus log z according to the laws of logarithm. So this comes to 2 log x plus 3 log y minus 1 minus log z. Take note that log 10 is 1. So that is the final answer. We have expressed it in terms of log x, log y, and log z. So that is the answer. Example 3. So if you want me to repeat something, just tell me there. Example 3. Given that log 2 is equals to, given that log 2 is equal to 0.3010, given that log 2 is equals to 0.3010, and log 3 is equal to 0.4771, find without using tables or calculator. Find without using tables or calculator the value of part A, log 72. Log 72. So that 72, you have to express it in terms of the 2 and the 3. If you express the 72 in terms of the 2 and the 3, you will get it is log 2 power 3 times 3 power 2. So this one is the same as log 2 power 3 plus log 3 power 2. According to the laws of logarithm, log 2 power 3 is the same as 3 log 2. Then we add to 2 log 3. And this is the same as 3 in bracket 0.3010 plus 2 into 0.4771. So you have to show the examiner that you are not using a calculator, and therefore this method is very, very important. So I have to see, find the 0.3010 times 3, you can just get it, you get right here 0.9030, and then you add 2, this one will be 0.9542, then when you add, you get 27581. So the answer is 1.8572. So the next one, part B, we have log 45. Log 45. Log 45. So log 45, you say it is 3 squared times 5. 45 is 3 squared by 5. So this is 2 log 3 plus log 5. We are trying to apply the laws of logarithm. When I say 2 log 3, that is log 3 squared. I'm following the third law of logarithm. When I'm splitting the multiplication to addition, I'm using the first law of logarithm. So the laws of logarithm must be used to answer these questions. Then this is 2 into 0.4771 plus, what is this log 5? A mistake that students will make, they will say it is log 2 plus log 3. That's not true. In fact, log 2 plus log 3 is log 6 and not log 5. Log 2 plus log 3 is log 6 and not log 5. So log 5 is actually log 10 minus log 2. Log 10 minus log 2. So this is 0.9542, but what is log 10? Log 10 is 1. What is this one? This one is 0.3010. Then you get your answer. So you have to show by adding. Just write 0.9542, add 1, get 1.9542, then subtract 0.3010, then you will get that answer. So you'll get 1.6532 as your answer. Example 4. Example 4. Given that log 4 is equal to 0.6021, log 4 equals 0.6021, and log 6 is equals to 0.7781, and log 6 is equal to 0.7781. Find the value of log 0.096. Find the value of log 0.096. So the log 0.096 is the same as log 96 over what? Over 1,000. Now 96, you express it in terms of 4 and 6, and you will get it is 4 squared times 6 over 1,000. So this comes to 2 log 4 plus log 6 minus log 1,000. So we are applying the laws of logarithm. So 2 log 4 plus log 6 minus log 1,000. So we put here 2 into 0.6021 plus 0.7781 minus 3. Log 1,000 is 3. Then this comes to 1.2042, 0.7781, add, this is 3, 2, no, this is not 7781 but 7782. 7782. So just change to that. It's 7782. This is 24. This is 891. Then subtract 3. Now, because it's not visible there, when you subtract 3, you will get bar 2.9824. Bar 2.9824. Avoid writing the negative answer. Avoid using a calculator. Manipulate them. Manipulate them. Here it's not visible, but you add, then you subtract. When you subtract, you should get bar 2.9824. So the log 6 was 0.7782. Then last example, example 5. Simplify without using tables. Simplify without using tables. So if I have log 20 plus log 5, so that one will be the same as log in bracket 20 times 5 which is log 100, which is 2. So don't leave your answer as log 100. So it is log 20 into bracket 20 times 5, which is log 100, which is 2. Similarly, if I have log 40 minus log 4, this is log into bracket 40 over 4, which is log 10, which is 1. Three minus log 200, this is log 1,000 minus log 200, which is log in bracket 1,000 over 200, which is log 5, which is log 5. Now, what about log 4 divide log 8? Can you try that and then raise up your hand very fast? I'm giving you just 1 minute. What is log 4 divide log 8? Do not use a calculator. What is log 4 divide log 8? Any of you? Log 4 divide log 8. What is the answer? Log 4 divided by log 8. Log 4 divided by log 8. Log 4 divided by log 8. So this is what you do. Log 4, you just write it as log 4 over log 8. But log 4 is log 2 power 2. Log 8 is log 2 power 3. And then log 2 power 2 is written as 2 log 2. 2 log 2. And then log 2 power 3 is 3 log 2. Then the log 2 cancels and the answer remains to be 2 over 3. So the log 2 cancels, which is not, you don't have to cancel, just write it as 2 log 2 over 3 log 2, and then write your answer as 2 over 3. 2 over 3. Another one. Half log 625 plus a third log 125 over 2 minus half log 16. So in the numerator there, we have the half log 625. So half log 625 is log 625 raised to power half. When you raise a number to power half, it's like you are getting the square root. So this is the same as log square root of 625. Then plus, this is log 125 power a third, which is log cube root of 125 over log 100 minus log square root of 16. So log 625 is the same as log 25 plus log 5 over log 100 minus log 4. So this is the same as